Today we will be looking at trigonometric equations, precisely conditional trig equations. Objectives are solving trig equations that are linear in form, solving trig equations that are quadratic in form, solving trig equations using identities, solving other types of trig equations, and lastly, solving trig equations using a calculator. Looking at some steps for solving linear trig equations. First, isolate the trigonometric function on one side of the equation. So get the trig part on one side of the equation. Determine the quadrant that the angle is in. Step 3, this first portion, is optional because you already know, you're responsible for knowing, so you should already know all of the common angles around the unit circle. If the terminal side of the angle lies along an axis, then determine the angle associated with it on the interval 0 to 2 pi, starting at 0, ending at 2 pi, choosing from 0, pi over 2 pi, or 3 pi over 2. And lastly, step 4, use the period of the given function to determine the solution. So please remember, tangent and cotangent from our previous chapter has a period of pi. All other trig functions have a period of 2 pi. An example, determine a general formula or formulas for all solutions to the equation the sine of theta equals 1/2. Then determine the specific solutions, if any, on the interval 0 to 2 pi. So from your knowledge of the unit circle and the common angles on the unit circle, you know that the sine of pi over 6 equals 1/2, as well as the sine of 5 pi over 6 equals 1/2. So the specific solutions are pi over 6 and 5 pi over 6. Now getting the general formulas. Of course, we can go around the unit circle an infinite number of times and stop in the same location, producing the same sine or cosine. So that leads to many answers, infinitely many answers, and we write those answers as formulas. So the answer going around this unit circle once from 0 to 2 pi, a pi over 6. Anytime you go around the circle, which would be going around the circle is 2 pi in radian. So it's that angle pi over 6 plus going around the circle k times, and k can be any number of times going around the circle. K is any integer. And then the same thing with the other angle, 5 pi over 6 plus 2k pi. My answer is in radian because I used 2 pi. This answer could also be expressed in degrees by saying plus 360k. Looking at an example that requires factoring. So now we have an example of a trig equation that is quadratic. We see the exponents 2, understood 1, and then nothing. So, just as in algebra with your quadratic equations, the first approach for solving should be to factor. Second approach, most common, is to use the quadratic formula. So this equation is factored just like it did not have trig. For example, if it was 2x squared minus 3x plus 1 equals 0. It's just now rather than x, you have sine theta. So this factors into 2 sine theta minus 1 times sine theta minus 1. As always, when solving, two pieces, two things that are being multiplied, they equal 0. We set them each equal to 0 and isolate the trig function by moving 1 to the other side and dividing by 2. What's over here, this one is already solved. So, our answers are angles that have a sine of 1 or a sine of 1/2, and those angles are pi by 6, 5, 6 pi, and pi by 2. We were asked only to provide answers on the interval from 0 to 2 pi. Now looking at an example that requires the use of an identity to solve. So the problem is cosine 2x equals cosine x. Of course, 2x is double x, so with this problem we can use a double angle identity for cosine. If we select the double angle identity for cosine of 2 cosine squared x minus 1, so making that substitution, replacing cosine 2x with what is equal to, according to this identity, we end up with an equation that when set equal to 0 is once again quadratic. So like the previous example, you will factor, set both parentheses, both factors equal to 0, isolate the cosine of x, and then identify the angles that have a cosine of -1/2 and a cosine of 1 for final answers of x equal 2 pi over 3, 4 pi over 3, or 0. All of those are solutions. Well, looking at our next example, if you attempt to solve this problem, tan x equals 2 sine x, you will find yourself just stuck, brainstorming and not able to move forward unless you make a substitution. So once again, substitute an identity, this time one of our basic identities, and it opens up the door, like in the previous example, of being able to solve by factoring. So replacing tan x with the identity or its definition of sine x over cosine x. When solving by factoring or attempting to solve by factoring, first step, set the equation equal to 0. This time, we do not have a trinomial, we just have two terms. But we have a GCF, we have a common factor of sine x, so we can factor it out. As usual, setting both factors equal to 0 and solving. Of course, the first one is already solved. We know the sine of x equals 0. But solving the other one, moving the 2 to the other side. Because if we move it to the other side of the equation, it becomes negative. But then when we divide by the understood -1 in front of 1 over cosine x, the 2 becomes positive. Going ahead and finishing up, if we solve this proportion by multiplying both sides of the equation by cosine x, you will get a final answer of cosine x equals 1/2. Of course, since this is a proportion, if you write in the understood or in your mind mentally visualize the understood denominator 1, you could also solve this by cross multiplying and dividing. Regardless, answers of sine x equals 0 or cosine x equal 1/2. Angles that have a sine of 0 or a cosine of 1/2 are 2 pi pi, pi over 3, and 5/3 pi on the interval 0 to 2 pi. So this problem is complete. This next example can be solved without a lot of drama by using knowledge that you already have. You are asked to solve the cosine of 2x equals 0. So we know we are trying to find an angle that when we take the cosine of it, we're going to have 0 because the equation is set equal to 0. And we know those angles are pi by 2 and 3 pi by 3 that have a cosine of 0. But when we examine closer, it's not the cosine of x, it's the cosine of 2x. So in other words, twice what amount? 2 times what equals pi by 2, and 2 times what equals 3 pi by 2. Well, to find that out, just solve both equations. Solve 2x equals pi by 2, and we find that x equals pi by 4. Of course, to solve, you just divide both sides of the equation by 2. Same method for solving over here. So solving 2x equals 3 pi by 2, we get an answer of 3 pi by 4, and the problem is completed with answers of pi by 4 and 3 pi by 4. This last example is similar. If we move the 1 to the other side of the equal sign, we get the equation, the sine of x over 3 equals -1, which means the root to solving this problem is going to be an angle. The main two we need is finding an angle whose sine is -1. And we know that value. You know that value. 3/2 pi, or 3 pi over 2, however you want to say it, is the angle with a sine of -1 on the interval from 0 to 2 pi, going around the circle once. Of course, just like the last problem, or very similar to the last problem, we were not given the sine of x, but the sine of x over 3. We know that angle that has a sine of -1, again, is 3 pi over 2. So we just have to figure out what angle divided by 3 equals 3 pi by 2. So solve the equation. You may clear your fractions by multiplying both sides by 6, or cross multiply, giving you 2x equals 9 pi, however you choose to do it. With 2x equals 9 pi, then dividing both sides by 2 to get x by itself, we find that x is equal to 9 pi over 2. And we have the answer on the interval 0 to 2 pi. For a general equation, not on the interval from 0 to 2 pi, but just continuing to go around the circle over and over again, we know the sine of -1 is repeated every time we go around the circle, every 360 degrees. So that answer would be 9 pi over 2 plus 6k pi. This answer is achieved by taking the equation x over 3 equals 3 pi over 2 plus 2k pi. Now just adding that the fact that we're continuing to go around the circle with the plus 2k pi, but then solving this equation for x. Of course, x is being divided by 3, which means to get x by itself, all the terms must be multiplied by 3, and that produced the final answer. In my math lab on the left-hand side of your home screen, if you go to the multimedia library, select chapter 6, section 6.6, video lecture series, and scroll down. After clicking the Find Now button, you will have a video provided by the author of your textbook, another video. As usual, on the content of the section, I do encourage you to watch that particular video. It gives a nice example, one found example that's really nice, of going around the circle many times, having 2 answers, as we did so again, there you're provided an example where you have 2 answers, as we have here on this previous example that has been covered. But the 2 answers are exactly 180 degrees apart. Therefore, you do not have to write them as separate answers as we did here. You just need to write the smallest one, and then rather than 2 pi, just put plus pi k or plus 180 degrees k,